Okay, let's look at number 26 from the free response packet. So we have this table, and what we got? A zoo sponsored a one-day contest to name a new baby elephant. Zoo visitors deposited entries in a special box between t equals 0 and t equals 8 from noon to 12. The number of entries in the box, t hours after noon, is modeled by the differential function that was given from 0 to 8. Values of e of t in hundreds of entries at various times are shown in the table above. So a couple things we should notice is, again, we should always look at the table and ask, what is it? Is it a position, velocity, or acceleration? In this case, it is a position function because the units are hundreds of entries, right? That's a position value, not a rate of change. Okay, from there, let's do letter A. So what do we got? Use the data in the table to approximate the rate in hundreds of entries per hour at which entries were being deposited at time t equals 6. Show the computation that leads to your answer. Okay, we're looking for a rate. So we are looking for, we are trying to approximate the rate of change at time t equals 6. So in other words, I'm going to say E prime of 6 is approximately, and then what I'm going to do is I'm going to use a slope between 5 and 7, right? Because 6 is between 5 and 7 in order to approximate that rate. So in other words, I'm going to say I'm going to find the slope between those two values. So in this case, I'm going to get this, which equals 4. So it is changing at a rate of 400 entries per hour at time t equals 6. Okay, letter B. Use a trapezoid sum with 4 sub-intervals given by the table to approximate the value of that. Use correct units and then explain the meaning. Okay, so first off, let's see what we got here. Kind of want to explain the meaning right off the bat, but I will go and we will go through and do the math first. Let's do that. So this right here, what is that equal to? So we're going to use a trapezoid rule, right? So let's just kind of, I'm going to grab this table right here for reference. Just going to put it right here so I can see it. Oh, that didn't work so well. Okay, well, I do actually have some numbers written down here, so hopefully you can kind of go through and follow along looking at the table. So let's see what we got. So this is approximately equal to, so what is it equal to? So approximately equal to 1/8, and then we're going to use the trapezoid rule, right? So what do we do? So I'm going to take, the trapezoid rules says I take the average of the bases, multiply it to the height. So I'm going to take E of 0 plus E of 2. I'm going to take their average, so I'm going to divide that by 2, and then I'm going to multiply that by the height of that rectangle, which is 2 minus 0, or 2. Then to that, I'm going to add E of 2 plus, what is it, E of 5. I'm going to take the average of those, and then 5 minus 2 is 3, plus, let's go with E of 5 to E of 7, I think. Yep, E of 7. Take the average of those two. 7 minus 5 is 2. And then finally, I think I can fit it in here. Let's go E of 7 plus E of 8. Divide by 2. 8 minus 7 is 1. Okay? From here on out, we are just calculating values. Okay, so we are just calculating values. So for me, I end up getting, this is approximately equal to 1/8. And that is, I'm going to just kind of simplify the math here. 4 plus 51 over 2 plus 34 plus 22. And that equals 171 over 16. And if we were to plug that into our calculators, we would get either 10.687 or 10.688. And they're asking for our units. So this is hundreds of entries, if that's how you spell the word entries. Okay, let's see. Then they ask, what is the meaning? What is the meaning? So the meaning is, so this right here, this thing right here from 0 to 8 of E of t dt, this is going to, so this is the average value theorem. So this is saying this is the average number of entries in the box from time 0 to time 8, right? Because that's our average value theorem. So let's just write that. So this represents the average, that's an important part, average number of entries. I'm going to put down in the hundreds because that's what it was, from time t equals 0 to t equals 8. So just before we finish that up, just a couple little notes here on my explanation that are important. So some things are important. One is that it represents the average number, right? Because we're using an average value. This represents the average. And then also from when to when. Okay, let's go on. Letter C, what do we got? At 8 p.m. noon, volunteers began to process the entries. They processed the entries at a rate of this function. So they gave us an entry. So these are being processed. This is a rate of change. And again, the units are hundreds of entries per hour. So again, it's a rate of change, and this is only good from time 8 to 12. According to the model, how many entries had not yet been processed by time t equals 12? Okay, so in order to do this, right, we need to know a couple things. If we want to know how many have not been processed, we need to know how many have been processed. So we need to know at time 8, how many things have been processed. So I think you'd agree, I need to figure out what is E of 8, and then I'm going to subtract the integral, right, the displacement from, I think it was from 8 to 12 of our function, our rate of change function, okay? So the E of 8 is going to give me the number of entries processed. The integral is going to give me the displacement, right? The number of entries processed from, sorry, let's repeat that because I said it wrong. E of 8 is going to represent the number of entries in the box at time equals 8. The integral from 8 to 12 is going to represent how many entries were processed from the time 8 to 12. So let's do that. So E of 8. E of 8 is 23. And then in our calculators, right, we are going to go through and integrate the function that they gave us. So what I ended up getting is I got 23 minus 16, which is 7. So there were, in this case, this is 7 in the hundreds, so 700 entries. I feel like that's not how you spell entries. Anyway, is it ENTR? It doesn't matter. It's probably ENTR, but anyway, it doesn't matter. So that's the number of entries that it's still not yet been processed. Okay, let's move on to letter D. Okay, for letter D, according to the model in part C, at what time were the entries being processed most quickly? So they want, be careful on this one, right? This represents a rate of change, right? They want to know when this rate of change is at a maximum. So in other words, if this is the first derivative of something, I'm going to have to go and take the second derivative of that function. So what I'm going to do, right, in order to find the critical numbers. So now it is asking for a maximum, so you have to be careful, right? a maximum could occur at endpoints or are critical numbers. So in other words, it could, well, let's do a couple things here. First off, let's go and take P prime of t and set it equal to 0. So P prime of t, that's going to be, let's see here, P prime of t, that's going to be 3t squared. I wish I could move that down. So it's 3t squared minus 60t. So 3t squared minus 60t plus 298 equals 0. And we're going to put that on our graphing calculator and get our values. So I got two values. One I'm going to call A, and that value is 9.1835. I'm just going to kind of take this one out a bit, 034. The other one is going to be B, and that one is 10.816496. Okay? Those are my A and B. Those are my two critical values. But remember, there's also endpoints, 8 and 12. So in order to find the maximum number of entries processed from time 8 to 12, I'm going to have to go find P of 8, right? I'm now going back to my original function given because I'm trying to find a maximum for that function. So I'm going to go find out what is P of 8, what is P of A, what is P of B, and then finally, what is P of 12? Okay, so plugging these into my calculator, I get P of 8 is 0. P of A is, I have a little trouble reading my handwriting, so hopefully this is right. I got 0.888662. Okay, I may be a little bit off, but it's not going to matter in this case. P of B is going to be 2.911338, and then P of 12 is 8. So I think you'd agree. The reason I said P of A didn't matter is P of 12 is our largest value, so it's at a maximum at P of 12. So I'm going to say at time t equals 12, the entries are being processed most quickly, And that is problem number 26.